welcome back to the Ground Investigation Podcast, where we delve into the world of geotechnical and geoenvironmental engineering with some of the brightest minds in the field. I'm your host, Michael Taylor, and today we have Dr. Santiago Caballero. Santiago has an extensive background in geotechnical engineering, working across multiple states in the US, from California to Texas and Washington, D.C. area, as well as internationally. With a PhD from the University of Texas at Arlington, and experience at Group Delta Consultants for starting his geotechnical experience to larger firms, now Geotech Consulting, among others. He has been involved in some fascinating and complex projects. Today, we'll be talking about his career-defining projects, the LAX People Mover and the SoFi Stadium. Unpacking the unique geotechnical challenges, seismic considerations and deep foundation solutions that played a critical role to their success. We'll also explore his experiences working in different states with both large and small firms, as well as his role as an educator, sharing knowledge in the US and Ecuador. Santiago, welcome to the show.
Well, thank you, Michael. Thanks for having me here. It's a pleasure to be here and sharing all the thoughts with you.
Perfect. So you initially studied construction management in Ecuador before shifting to geotechnical engineering. What was it about liquefaction and deep foundations that caught your interest and led you down this path?
Yeah, well, it's a long story when I started all my civil engineering career, but essentially, right after school, you don't know what to do, right? After your bachelor's, got my bachelor's in civil engineering back at in Ecuador, South America. And after graduation is basically what should I do, right? And then these ideas come to mind, like structural engineering was was there because my dad is a civil structural engineer. And it's kind of really cool to see all the structures, and then you think like everything goes around structural engineering, and then construction management was also there because that's kind of where you're making the most of money in a civil engineer project. But so that's the idea. You come after school, but and I started working in construction management and as assistant construction manager, and then pretty much supervising the contractor, making sure they're delivering and they're quantifying things as they should, right? And then there was a lot of geotechnical aspects there, like ground improvement, that I didn't pay attention back then. I thought it was like the soils guy, right? How we call it, the soils guy needs to be taking care of that. But I was like mostly focused on the structural part. And then my second job in Ecuador was basically in a design team. We were pretty much designing the foundations, right, for energy plants or energy equipment related for the plants and gas plants and refineries and stuff like that. We were actually the guys receiving the geotechnical report, and so I was reading it and I was like, oh, they're giving me this capacity of soil and stuff like that, but very very basic things that you don't pay attention to it until one project where we were doing, the project was on the coast of Ecuador. As you may know, Ecuador is like, is located in a seismic zone, subduction zone. Earthquake was an issue. Loose sands and, granular soils were there. High groundwater table. And then, of course, the soils, the engineer, geotechnical engineer, came into to the meeting, and then he said, oh, we're going to have a liquefaction issue here. And then I briefly remember about what liquefaction was from school, trying to understand what he was trying to recommend as a foundation system for for these generators and turbines for the electrical plant. And then he was a very sharp guy, MIT graduate, master's, and in geotechnical engineering, came to the meeting and then gave us pretty much like a presentation about liquefaction and piles. I was like, is this something, I asked him like after, is this something like a geotechnical engineer do like in the real world? Like, yeah, this is geotechnical engineering, and this is what basically we most of the time we deal about. Um, and then since then, I was like, well, I think what I learned in school about geotechnical engineering, that I thought it was like, sieve analysis and plastic limits and liquid limits and all that, or like, that's not what it is. I think I need to, kind of make myself available to explore more about this field. And then we had like a lunch meeting with them, and then I was able to kind of ask him a few questions. I was in the position to go for a master's. I was trying to get a master's, and I didn't know exactly which field I should go to. um, and the problematic of, or like the effect of recommending the foundations into the project was very, very critical for the client, because at that time you're talking about like 10 times the cost of between a shallow footing and a deep foundation system. So, the client was shocked at the very beginning, because, kind of the budget, of course, went up, and then just because of foundation, it's something that you don't even see. So the client was like really concerned, like, oh, should we really need this, right? And again, this presentation gave him like a really sense of the need, right? And then why we need it, why it's important. And of course, we have really sensitive, or like structures really sensitive to settlements, right? Like you're talking about pipes, gas pipelines that are crossing, turbines and generators that are really, sensitive to these small displacements. So we just can just not allow any criteria more than we're supposed to handle. Those pipes are supposed to handle. So after that, I was like, I think I'm just gonna go into geotech. And then, my dad is always kind of a person who I talk to all the time, and it's like, he used to work as a consultant too back then. And then they were doing a lot of dams and levees projects in Ecuador back then. And then he was telling me that a lot of geotechnical feedback, and then consultants are coming from abroad, because Ecuador doesn't have any, or like they're really limited. So like, and then at that time I learned like about all these different fields, or these different topics that in between, within geotechnical engineering, that you can focus yourself and start developing new things, and learning about new things. So after that, I decided I should go for geotech. And then I came to school, to the United States later, California, and then I kind of started my career from there.
And the rest was history, as they say.
Struggling to find top geotechnical and geoenvironmental talent? You could use a generalist recruiter, or you could use a specialist. At Geo Expert Search, we place experts where they belong. Across the UK, USA, Australia, and New Zealand. No highways, no bridges, no structures. Just geotechnical and geoenvironmental. Now and forever. Geo Expert Search. Finding the right people for the right roles with no wasted time. Visit geoexpertsearch.com to learn more.
You've worked in several states and internationally. What key differences have you noticed in geotechnical engineering challenges across different regions?
Well, it's one of the things, from the very beginning, right? From planning purposes, we're talking about how are you going to sample, how are you going to drill, which method of drilling are going to be doing, right? And it really depends what is available out there, right? If we're comparing like small country of Ecuador, like compared to the U.S., let's say, right? The limited equipment that we have down there, it's what we have, right? And then of course over the years we have improved, and then we have started using, for example, CPT and dilatometers and all that, in Ecuador. But I think, what is available becomes really, what you use in geotechnical engineering from planning purposes, right? Because that's how everything starts before, when you want to start doing explorations. So, I think that's the main factor, right? What's available out there for you. But sampling, for example, is also different, between regions. I started my career, in California, and you start talking about the modified California sampler. Of course, the SPT is there, and the CPT is always, kind of one of the most widely used methods, here in California. But then I moved to Texas, and then, Texas, we don't have a modified California sampler, right? And then there's a bunch of Shelby tubes that we collect, that not as much in California as but we do that in Texas. We don't have CPT. I mean, there is not much need for CPT, and so you don't have contractors in, CPT contractors in Texas. And then as I moved to the east, sampling becomes, for example, was something very different as compared to in between these regions. Driving an SPT sampler from 18 inches in California, and most of the time on the east is like 24 inches, right? All the time. It's like a standard thing for them. So it's definitely something, that it's very different from one place to another. SPT is very common. In Ecuador, uses SPT, and then all the countries I work for is pretty much SPT is what it's available. When you plan something and when you suggest something to a client, you have to be very careful what is available out there again, because you wanna say, oh, let's use CPT. I'm like, well, what is that, right? Because we don't usually use that in here. And then that's kind of as far as the planning, and of course the laboratory testing is also changing across the regions. We Most of the time there are places that we still rely on natural limits, for example, right? Some places that, like I said, we just use SPT, CPT. It really depends. We have got in some regions got away from those attribute limits. We don't use them anymore, right? Undisturbed samples, undisturbed, and I call that undisturbed, but there's not relatively like undisturbed sample, but California and undisturbed sample, it could be considered a modified California sampler, but it technically, Shelby tube can be more accurately like getting an undisturbed sample, but we also use, in other places we have used the sugar block sampling, right? That's a different sampler to collect undisturbed samples. So I've seen like in other areas that we freeze, for example, the samples to preserve the void ratios, right? Something we don't think about. I mean, it really depends on the project and the quality and the, what are you trying to accomplish in your modeling or your analysis, right? But um, again, changes from region to region. I've heard a lot of people from Australia, they now freezing samples for a tailing dams project, right? So and again, it's really what you need, but there are different techniques that we've been using across the regions, just to make our geotechnical analysis more accurate, right? And then how we use correlations, maybe for CPT and SPT is also a big factor at the end. Um, we're getting our soil parameters based on those correlationships, right? And then I've seen people do not rely on SPT anymore. And then if you read reports, probably CPTs are kind of the ones that are being used, and now they're being questioned, right? They're being used over the past 20 years, and now they're being questioned about it. But we've been using for 20 years. SPT were there for 60 plus years, right? And then everything has worked fine. But we are, as we move in geotechnical engineering, as we advance, right, we're trying to come up with more efficient solutions, not just very simplified methods to come up with properties that that can be critical at the end of the day. And then we can talk about the cost effective later of the projects, for example, that we're going to be talking today. But essentially, it all starts how you correlate things. And then regions using is based on local experience too. So at the end, you'll be working with experienced geotechnical engineers and locally that they know for this geology I work with this correlationships, they work pretty well. That plays an important factor when you start using some literature available correlations. So experience is always there, and then you have to have someone that has that experience to share with you, and on that aspect.
Sure. So, in relation to the LAX People Mover, so it's massive transportation infrastructure project. What was your role in the project, and what was the biggest geotechnical challenge you encountered?
Well, I think a lot of challenges there in that project, but I was very lucky to have that experience, as starting my geotech career, because you don't get this project, many times during your entire career. So I think my involvement started from simple things in a way. Well, in LAX, the airport, everything is complicated, but was involved in the field work, how to manage the staff, what type of samples we need, right? To where we're gonna need to collect samples, what laboratory assignment we're gonna do, and it really depends what type of analysis you're gonna try to do, right? At the end of the day, and of course that was kind of one part, but it goes along about the logistics that the airport had, right? And all the things that they were asking you, or you were forced to use, right? And there were certain limitations, like for example, schedule, right? You can only drill like overnight, for example, and that becomes like a problem, you have to rotate people, right? And so that kind of helped me to kind of manage a little bit of the people on staff, right? And at the end, what you want is like you want to have like a really crucial communication with staff, because you want to understand you want them to understand what you're trying to design and what you're trying to collect out of there. Every single thing that you write down in a log, for example, or like in your daily, can be very important and critical, even for construction phases, right? There was like ones that in construction you just pull out a boring log and they show like, oh, the soil cave in at this depth. That might not necessarily like important at the time of drilling, right? Because you collect your sample and you're good, but might be important for the contractor to see, what that localized problem could be, right? For construction, for example. So I think what I learned, or what I was involved, was this initial part of drilling, logistics, and then doing the analysis of those large diameter piles later. And that was really, kind of something that you don't learn those things in school. You learn the basic, I don't know, pile capacity methods, alpha and beta method, right, in school, and it's very straightforward. But when you actually start seeing how the piles are being or how the piles are affecting, for example, the adjacent structures, and impacting, utilities that are critical for the airport. That's something that you don't think about in school, right? So it's it was a lot of challenging logistically, of course, but the design as well, right? Because of all these limited space that you have in the airport. And then if someone has been in LAX, they know what I'm talking about. Traffic, it's crazy. You have utilities for every single thing that you can think of, even like the black utilities that they call them. Utilities that you don't know where they are, right? So you can either hit them when you drill, or you can either hit them when you construct the piles. So, and then just imagine if you hit one of those, and then the FBI can just come and just shoot you down for you'll be in trouble. But all these challenges, limited space, design wise, adjacent structures, it's something that you don't think about when you design a pile in school, right? It is like, oh, you get the soil parameters, right, straightforward, and you start designing with a method, and that's it, right? So there was a lot of thinking, a lot of logistics on the back. Of course, experience, like I'm saying, experienced geotechnical engineers on the backside, right? Because I was starting just my career there, no idea what I was doing. But of course, you have to have the proper guidance, and there's certain things that they think, that you don't think at that time, and then they help you. It's like, oh, we should think about, how you're gonna locate your rig, right? You have these. You have these head, like overhead, like located there. Just small things you don't even think when you start your career, right? Experienced engineers, they help you to kind of understand a little better how to tackle those problems.
Sure. So you mentioned about the adjacent structures. How was it in terms of the interaction and seismic considerations, I suppose, of those adjacent structures?
Well, it was very challenging. I mean, you have structures and utilities, right? Not only structures. Then when I said utilities, you have tunnels, like sewer tunnels that crosses the airport and stuff like that are really critical for the city, right? And then you have all these big shafts, like 10, 12-foot diameter shafts, right? Drill shafts, or the proposed piles that are kind of located 3 feet away from the edge of parking structures, or like from the edge of pipes and tunnels, like I said. So very, very, very challenging that aspect. So there was a lot of analysis, right? That we had to do a 3D modeling of the shafts to understand the impact on existing structures, and primarily because of the ultimate seismic loading that we're going to have, right? It's a seismic area, and then we have three different jurisdictions where you have to kind of come up with the design spectrum, right? You have Caltrans, California Transportation Jurisdiction. You have City of LA, and then you have the County of LA as well, I believe it is. And then so you have to come up with the design spectrum for every single thing to understand what is the impact, right, of this, what is going to be the seismic demand, right, and then the impact after you do the 3D analysis. So and then we not only verify the displacements of the movement of the lateral movement of the piles, we also had to analyze or assess the maximum induced pressures from these piles to existing utilities and existing structures. And there was a lot of flat 3D analysis that back then we perform. And of course we one really cool thing is like how these stresses and deformations are dissipated with distance, right? That's what you want to know at the end of the day. Like I'm saying, you have 3 feet of spacing just between your proposed pile and the existing structure. For example, the parking lots in LAX, and those parking lots are not the best, and I'm not supposed to say this, but I mean they're all structures, right? They're trying to be retrofitted over the years, but they're really tiny piles, right? Like if you compare and I always when I talk to kids and stuff like that, for me to understand what I'm saying is like, just imagine if you have like a huge tube, right, like steel tube, trying to push laterally like a really kind of tiny tubes or like tiny straws that are supporting like a parking lot, right? Those straws are not going to resist any lateral movement coming out from this big pile. So it was definitely something that had to be considered, and then it was challenging in all senses. That lateral displacement analysis and the stresses that we have to evaluate, that dissipation was very important.
So this was one of your first projects. Was it your first kind of real life projects? It must have been quite pressurizing to be on such a complex project, but such a kind of, I suppose, famous project, such an important project. So many things could go wrong at any moment. How did you deal with the pressure of all of that? How did you all deal with the pressure of that?
I think, like I said, it all comes when you have a team, right? When you have a really team of experienced geotechnical engineers and you're working with really, smart people out there and very brilliant in all aspects. I had the opportunity to work with, few engineers that in that project, but um, they were able to kind of walk you through the anticipated problems that we may face, right, at some point. And then planning phases or design phases, it doesn't really matter. So it all depends on who you're working with. And then I was very fortunate that I was working with, like I said, very very experienced geotechnical engineers on on these type of projects, that you feel like so comfortable, talking to them, working with them, asking questions anytime you need, right? Because of course it's something that's definitely new for you, and as a starting geotechnical career, you want to have that support. Because if you're alone there on these big projects, that you're probably not going to be there, by yourself. But if you, let's say, that was the case, um, a lot of things can go wrong because you don't have the experience to do that. So you definitely need to have that support. And then for me, I think it was very very vital, the team that I was working with, the people that I was working with. The president of the company was involved, and then you can find him. You can walk through the hall, and then you can talk to him, like freely, having these conversations, technical conversation. He's like very open to share his knowledge, and that gives you the confidence. Every day having these conversations, you're getting more knowledge outside the project, right? And then when you start doing the design, you're like, okay, I know what to read, I know which concept I should use. And if you're not sure, you can ask. There's always a person you can ask, and then you get that feedback, and then it helps you to kind of develop that confidence, right, for later. But it's very very critical that you have to have a team in these type of projects.
Yeah, I suppose it's a great way to sharpen your skills very quickly. So I suppose along the project, was there anything, was there any innovative geotechnical solutions that had to be conjured up because maybe something in the plan wasn't quite as was or as expected?
Well, I think more like a solution was something that we have to think uh, when we actually designing this, right? And then of course when you're in school and when you're a student, you don't think about these things. Is for example the pilot testing, right? The program. And then there was a need for pilot testing. And then, we're talking about 10 feet diameter piles, with the nominal capacities of 12,000 kips, larger than that sometimes. And the objective was to keep all the piles, of course, above the groundwater to eliminate the use of slurry, in some areas, and to minimize the delta effects as well, right? If you're dealing with water. But we tried to put together a pilot testing basically for two things, right? It was located in the city of LA, and then we were trying to get the approval to use end bearing for drill shafts, right? Like I said, we were trying to keep the pile above groundwater, like I said, to eliminate the use of slurry and to eliminate the delta effects that we may get, due to subsidence and settlements and all that. And then to do that, we had to use end bearing, which you don't normally use for drill shafts, right? So we had to use a pilot testing to demonstrate that end bearing was there, right? And then we had to kind of clean the bottom and stuff like that. And we're talking about 100 foot deep pile, right? Like shaft. So very complicated to convince the city that we're going to be using end bearing in a 100-foot deep pile. And then also another thing was like to use a higher ASHTO resistance factor for end bearing for the strength limit state. When you have a pilot test, you're able to use a zero point 0.7 factor versus the zero point 0.5 that you have to use without the pilot tests. We were using ASHTO method, right, to design the pile. So I think we suggest to that we were trying to understand, like, if this pilot testing can give us like a good sense of the behavior of the piles, that we can increase the capacity, right, and bearing. And I think that's something we put together to kind of again convince the city, right, and then make sure they're like okay, like letting us use end bearing, because otherwise your pile is gonna go underwater, and then you have to use a slurry. It becomes really expensive. You still have to deal with the groundwater effect that if you get groundwater pump over the next 20-30 years, then you're going to get some subsidence and some settlement of the pile. So it is complicated, right? So um, I think the pilot test program was very important for the project. It was very critical. We have, I believe, it was three different control areas where we had a pilot test along the alignment, and we were able at the end to demonstrate, some of the. We have good findings about the pilot test. At the end of the day, everyone's going to agree. I mean, the pilot test is what the real capacity of the pile is, right? Because you're actually testing it, but you don't have the luxury of doing pilot tests in every project, right? So in this case, it was very, very critical, although it was very expensive, right? Just imagine to mobilize equipment just to test, 3 piles, or like I believe we tested 5 piles, 5 CIDH piles, 10 feet or 11 feet diameter, in LAX, right? So it's very complicated to convince the city that you're going to do that, to overcome with the with some restrictions that you have from the city itself. So it was very challenging there. And then for installing these as far as construction for installing these piles, I was not part of the construction team, but I've been following this project after I left, and of course reading the news and stuff like that. They use a lot of crazy construction equipment. Of course, they work with a contractor to make this happen. How to install some sort of casings, right, to these 100-foot deep piles. They use for the load testing, for example, bidirectional load cells, strain gauges. They also had to use a clean, huge bucket so they can clean the bottom, and also, they can do the shaft inspection. It was just amazing, how they actually start testing it, and then building these piles, right? And then later when we had the data, it was very interesting to see because you get the, like I said, the actual pilot test data, and then versus the data did the capacity that you design or you analyze, right? And of course, we installed pilot tests with the wet method and the dry method, right? Just to compare how accurate the ASHTO method was. And then it was funny because there were few methods that we said, well, I think the dry method had like lower friction as compared to the ASHTO, and it was because of the very dry sands that we had in the upper or in the shallower depths. And the wet method pilot tests were having higher friction than the ASHTO, and it was because of the addition of the some clays that they were providing some extra strength there. So really, really, good findings and outcomes about the pilot test. And at the end, like I said, the pilot test is the answer you wanna get, right? She should be able to get the real and the actual capacity, right? So very, very interesting, and the type of like I said, solutions and methods we use and what we propose to convince the city and make sure they're okay with our approach. It was very, very, very great.
Were there anything learnt during that project that you've kind of carried through to future work?
Yeah, well, I think a lot of basically to be organized for every single detail in the starting from geotechnical, field work, let's say. Like I said, every single thing that you document, for example, in a daily report matters in this kind of big scale project and in any project, right? But it's very critical that you keep some organizations in logistics and how you keep things very clean and neat, in case you need them at the end, right? It's very informative. Whatever note that you put down, it's, like I said, even for later in construction phase, they can just refer to your logs, and it's amazing that sometimes the answer is there just in a field note that you have. So always be mindful about what you're taking notes, about what you see out there during geotechnical explorations. Is, I think, is one of the lessons I took from this project. And of course, be communicative with the entire team about your findings, about your approach, right? You also learn that design codes are not always accurate, right? We always believe, oh, we're designing per the code, but it's there's has to be some engineering judgment to there, and then there's a way to do, and that's where the innovation and how you're thinking out of the box come into place. Because if you think ahead of things and then you use your judgment and concepts, right? um, uh, Maybe you can overcome with the not just follow the code, but you can just provide an answer that is going to be better for the project. Might not be exactly like the code says, but if it's supported, let's say, by the pilot testing, right, and you give them like a good explanation using concepts, then there might be jurisdictions that are like, okay, we understand the risks, but I agree with the approach. So like I said, pilot testing might not be always possible, but there's always some experience there behind the design. And again, it comes to the team, right, who you're working with, how these experienced team and locally, right, in that specific geology previous projects, how they can help you to understand the behavior of your structure. So it's a lot of um, kind of lessons that I took from this project, just organizing things, talking to the team, and of course follow the codes, but think why the things on the code or the rules on the code, factors on the codes are there, right? Because sometimes you can overcome with different things, and then that's important for you to understand that it's there.
Sure. So going from one big project to the next, SoFi Stadium is an engineering marvel built in an area of significant seismic concerns. Can you walk us through the specific geotechnical challenges of that project, please?
Uh, yeah, it was a very interesting project too. Had the chance to to kind of work as a early geotech career here. But it's a 5 billion NFL stadium, right? So the owner essentially said, "I want my stadium here," and then he didn't care about how much it was gonna cost. He just said, "I want to have my stadium here." So some engineers said, no, it's impossible. We have an airport nearby. We have a seismic zone here. But of course, engineers are really, are there. We're here to provide solutions, right? And then I think that's one of the projects where there are like a lot of solutions were given to the client, to be able to have this stadium. So essentially what you have is you have a structure that has three different structures. Basically, you have the stadium itself with stairs, right, and you have the roof, and then you also have the buildings that are next to the stadium that are kind of separate to the actual stadium field, right, if you want to call it that way. So um, and then it all starts with the seismic aspects of the design of the, I think it's a 1,700-foot long base isolated roof. And if you see pictures of how this roof is kind of the aerial views in Google and stuff like that, in Google Maps or Google Earth, that you can see this big kind of rounded shape and a weird shape of a roof, right? And it has like 17-foot long, right? Like from point to point, like the farthest points apart. So and then you have the Newport Inglewood fault, right, which is like an active fault in Los Angeles area, which is like zero point 0.3 miles away from one corner of this roof, right? So there was a major ground motions study with near field Newport Inglewood fault effects. Like I said, fault is about 0.3 miles away from the stadium. There were ground motion time histories developed for the ground surface, and also ground motion time history developed at depth, just to perform numerical modeling. Um, One thing important here was that there was an evaluation of spatial variability of seismic or ground motions. We had to consider the wave passage and differential side response effects, right, across these long span arc roof abutments, just to estimate the potential seismic differential settlements, not settlement, differential displacement, sorry. And just think about it, this roof is has like fundamental period of structure of 10 seconds. So I think it's based on what I heard was I think it's the largest structure with the well no it's the structure with the largest fundamental period in the world. 10 seconds. Just imagine how big that is. So um, and of course this design came from from the architect, and then they just give it to you, and then you as an engineer, there was a lot of coordination with the structural engineer, right? And then the geotechnical aspect also kind of differs to how you're going to build a stadium, right? Like close to LAX, right? You have the seismic aspect there for the roof. Okay, we can design it, we can provide how motions, blah blah blah. But what about you're not supposed to cross the flight's pathway over the airport, right? So you cannot just raise a stadium above ground surface. So there was a solution saying, well, we can dig down, right? We can just excavate and then put the stadium down there. So if you walk into the stadium, you see the field, right? Like the stadium field, you see at the bottom, because it's actually like 100 feet down from the existing ground surface. The stairs are actually, if you're coming down as you walk in. So it was very very kind of innovative solution, right? Now you have these 100-foot excavation just to place the field right at the bottom. How are you gonna support that, right? So um, of course that as soon as you hear like you have 100 feet below ground surface excavation, that triggered a lot of geotechnical challenges, right? Initially we had the concept of a tie back wall, right? And then we did a flat model to understand the displacements using the seismic, seismic demand from the Newport Inglewood fault. But at the end, we came up with a new concept to perform the MSE wall, an MSE wall, mechanically stabilized earth wall. And then it was a pile supported stadium. So essentially you have the MC wall, and then you have this big roof, which is going through the MC wall and supported in shallow footings, and then you have the inner structure, which is the stadium, sitting on piles, right? So subsurface, I think the subsurface material was not kind of a main concern. Groundwater was not a concern. Liquefaction, we have really kind of decent clays, decent sands that liquefaction might not be, was not an issue, right? It was just mostly about the seismic displacements, and then of course you have heavy loads from the stadium itself. That's why the need of piles. But other than that, it was not problematic soils overall. Now, when you have the embassy wall all around it, right, like a wrap to the field, the problem now is that you have massive columns, right, that we call them blade columns from the roof that goes into the embassy walls, right, and then to be supported in the spread footings. Now, just imagine these columns when you have a seismic movement, right? They're gonna move laterally, right? And they're gonna be pushing your MSE wall at some point. So they had to be isolated with a casing. And then I believe the spacing that we had between the columns and the casing was about 3 feet or 5 feet. I'm not sure what it was. But just imagine your pile was gonna deflect laterally 3 or 5 feet. And then we had to kind of put like a casing there, so you don't have that, the MSE wall won't have any effect from the seismic displacement of the roof. And then on top of that, you have to have some anchors attached to these columns. So we call it deadmans, that they were like attached to behind the MSE wall, right? They were trying to to help with that lateral movement a little bit. So it was a very, very cool, work from the structural engineers. That of course we, our input was to provide how much lateral movement that those, we need in between those columns, right? We had to give him that motion for the column to be designed. So uh, it was just crazy to see it. And then you have these big excavations just to put your MSE wall, right? The Geotech style, right? You probably have seen an MSE wall before. And then it really starts with your Geotech style and compacting soil. So it goes all the way up. It was just they recorded the actual construction over the period of 3 or 4 years, I believe it is. It's just amazing how you see being built, from the excavation all the way to the top. Just great, great, great to see.
Sure. So, how would you balance the geotechnical risk with cost-effective solutions on working with such high-profile projects? I suppose people who are building huge football stadiums close to an airport have very deep pockets to start with, don't they? So it's perhaps not as pressurized. Would that be fair to say?
Yeah, well, I mean, for risk, I think ground motions, for example, aspect was, we received the support, and it has to be peer reviewed by various experts in the field, right? It was not just something that you come up with as a company and then you just provide to them, right? This had to be like very, very reviewed very, very in detail by various professors and experts in the field. They provided feedback, right, about the ground motions that they were able to implement and add new things, not only you know not only things that we normally use, right, but they've been studying for years. So as far as risk, you had that support, and the city, and of course the client had that support as well. At the end, they're spending $5 billion, right, in the overall the construction and everything. These additional analysis and assurance that you're going to have, and the budget at the end of the day is just nothing compared to the actual cost, right? And then I think for having the cost-effective solutions, there always has to be a conversation with a contractor, what you're able to perform. Besides your design, of course, you're going to be the designer, but there's always had to be a conversation with contractors, what is available out there as far as equipment is, if it's doable or not, if it's easier to do it or this way or not. I think in a project like this, we can just use simplified methods either. Um, we cannot just, come up with, for example, for analyzing pressures, you cannot just say, oh, I'm going to use ranking columns method, right? It has to be like more substantial and deep analysis to provide demands, right? And then it's just a way to, for example, you perform numerical analysis. We perform numerical analysis in all this flaxes, right? And this is to understand the displacement. It's just to reduce the uncertainties that we may have. And then at the end, we're going to be more cost effective, right? Mindful about this, because otherwise you're just going to put like a huge retaining wall and make like entire huge excavation or tiebacks and all. Might be safe, but it becomes really really expensive. And then at the end, you have to convey all these things to the client, right? Because at the end, like I'm saying, is their investment. So you know you have to not convince them, but you have to convey and tell them this is actually beneficial for you, because they may not understand numerical analysis, they may not understand this numerical modeling that we're doing, the ground motions study and the need of it, but you have to convey the proper message for them to, hey guys, this is your investment, you know this has to be done this way to reduce the risk and be more cost effective, right, in all senses, from design to construction. So we cannot just underestimate the need of advanced tools, right? We want to provide a better understanding of soils and how they behave under these specific and local conditions.
Sure. I suppose you have to have a conversation with the client then where it can look, and it is more of an upfront cost, but over the lifetime of the structure, then it's intended for it to, of course, be more efficient in terms of cost. So, you've worked in Texas, California, and Washington. How do regional geotechnical conditions approach your projects at each location?
Well, it is very, very definitely very different. Um, I think, well, I shouldn't say this because, there are people working in Texas, working in DC, but I think California has unique challenges, right? And then I've always said to students when I teach class and stuff like that, civil engineering classes, I was telling them that they are like located in a privileged area, right? Because there's a lot of things as a civil engineer that you need to think about. um, I think Texas, of course, has its challenges, has expansive soils, karst areas, and stuff like that. That leads you to different geotech challenges, where it's kind of a little more straightforward in terms of geotechnical engineering. And then DC is like kind of a very it has like various different things. Geology can be different from one area to another one. You have very some areas that are very restricted in space. That for example, if you want to do any project in DC, right, there was a project that we're crossing the tunnel, right. You have a lot of utilities existing, old bridges and historical bridges. So it has its own unique aspects, each one of them, right. Geology, like I'm saying, of course, plays a vital role, right. So understanding what we expect from each side is very important, right. So prior to any drilling or any going out there and start doing any collecting samples or anything you want to do, you need to understand what is out there. And then the availability of for example, geology maps or historical boring data is not everywhere. And then unfortunately, you're not going to find, sometimes you don't find like historical previous reports of a closer site or like a nearby site that you can check and you can understand like what you're going to expect. That really changes from jurisdiction to jurisdiction. California, for example, has very detailed information in terms of this. Texas might not have the best, and you have to kind of, rely on experienced local engineers, right? That may tell you, well, the geology here is this, or even in this area, you may not have a lot of boring log data available, and then it's important to have the conversations, right? And say, well, no, these are residual soils. I've been drilling here for so many years. This is the type of soil conditions you're gonna get. And again, it goes back to the experience again. But each one of these locations has its own aspects. Not mentioning Ecuador, right? Because Ecuador, we don't collect or store any any geotechnical or geologic data. So we are relying again on some local or previous engineers, nearby, and then that's what we have to do. Experience becomes later an important factor in a specific area that you're working on.
In terms of career advice, let's say that there's someone looking to potentially go into geotechnical engineering as a career. What advice would or could you give them?
Well, I think when you start your career and then you're gonna start interviewing with a lot of companies, right? I think one of the key questions that you should ask is which projects I'm gonna be working on, and then you just not need to get a. I mean, what you don't need is a general answer. And, oh, we have a residential project, we have retail project, we have transportation projects, dams and levee projects. Well, we want to know exactly, like, at least few projects that they're expecting, or that you're going to be involved if you get hired, right? And then how the team and the group, and it's a fair question, right? Like, as an entry level, and as a candidate, right, to a company, I want to hear that if I interview somebody, right? Hey, what am I going to be involved on, right? What type of project are you working on right now? What type of clients do you have right now? What is your daily activities, right? How do you get involved? Um, and then trying to get that answer from the actual team. I think that's going to be important for anybody who wants to start a career to make a decision, because you can just pick a job by company names, which I don't think is the best, right? It's just like you need to go by what they're actually doing, what they're actually working, because you can learn so much in a small project, right? Like in a really tiny project, you can learn way more than if you go to a large company. They're working on a huge project that you may be involved in this much. So in this small project, maybe you're going to be involved from 0 to 100%, even construction, and then you're going to be learning a lot instead of just going to this big project where you're just going to have, I don't know, just login data and you didn't pass from there. But although it's a big project, you get excited. So it's always important to understand what type of activities and tasks you're going to be involved, and that's a fair question, like I'm saying, during interview. So um, and then again, they have now in geotech, it's amazing because we have different fields of different topics that you can focus your attention on. You have ground motions, dam and levees, deep foundation, numerical analysis, right? Some of them have decided to do project management, right, from a geotechnical perspective. So um, it's really important to see what you actually like, right? Because you cannot just join a team where they're going to be doing, let's say, geotechnical construction CQA if you want to do numerical modeling, right? So it just doesn't make sense. It doesn't align with your interests. So always ask the projects are going to be about, what are you going to be involved, which tasks are you going to be working on, which people you're going to be working with, and talk to them separately. Like, talk to them during the interview, ask them questions. Don't be shy to ask questions during an interview, because that's what matters at the end. Don't go by the company name. Don't go by, like, oh, it's super exciting to work in here. Just go what you're going to be doing, because that's going to be passionate. That has to be passionate along with your own desire of learning new things every day.
It's good advice, and it's not just about the money either. Some people will choose because of just money, but most people want to know about the projects, what what the company is actually going to be doing. Smaller companies are great for, the candidate having more responsibility, learning a lot more of the things because there's nowhere to hide. So you're not going to be pigeonholed with a huge company and become a bit bored and stale, although that can be, that's ideal for some people. But yeah, asking questions, otherwise you're just not going to know. So you actively lecture in the US and Ecuador. What drives your passion for teaching?
Well, I've always liked teaching. I mean, it was a debate when I got my PhD. I was trying to see if I should go to to the academia and start being a researcher 100%, or if I want to go to the industry. Just because teaching, right? It was not, and I think at the end it was the main factor was, and then someone told me, I guess, yeah, someone told me if you like to do research 100%, then you should go to the academia. But not because you like teaching, you should go there. Because teaching is always going to be there, even though if you're in the industry, you can always teach part time. And I remember this happened in an interview when I was doing that. Um, uh, and then since then, I was like, okay, I'm just going to go to the industry. Um, and then later, of course, when you get some experience and then some exposure, right, you want to start sharing all these details or things that they are learning to the students. And then I think teaching was always there, like I said, and then now it became like an opportunity for me, to kind of share all these knowledge. And then yeah, so like again, I think it was always there. It's just a matter of the perfect timing, right? What was the perfect time for me to convey and then to give back a little bit about the industry, what I learned in the industry.
So how do you incorporate the real world project experience into your lectures?
So I think every single concept, that I try to teach in class goes along with the real problem or challenge that I have faced, in the industry. I always have like an example of what the problematic could be, why you're designing this, why you're doing this, why are you using this formula. Um, you know, I'm not just there to kind of show formulas and throw the formulas on the board and like, and this is going to be your cheat sheet and then just pull it out and then it's just a mechanical problem and that's it, right? Because I mean, at the end, geotech, sometimes it is what it is. You use like a set of equations and you come up with something, factors of safety or type of thing. But I think they need to understand what the role of a designer or contractor could be. When you provide, for example, earth pressures, right? Earth pressures coefficients, something that is very simple. Who is going to use that, right? Sometimes as a student, it's not just getting the number, right? It's just understanding how that number is going to be used, or who is going to be using that number, who is going to be looking at this number. Some kind of basic things that in the school I wasn't taught that way, and then I wasn't conveyed the message that hey, this is how they're using it. Now, if you're a geotech, you're providing this, but who's going to use it? Who's going to look at it, right? And then where are they going to do it, and what can I do better for that number to match the expectations, for example, from the structural engineer, right? Um, so it's just a matter of making them understand how that concept is being used by others, right? Not only as a geotechnical engineer, what you need to put in the report or what you need to put in our recommendations, but it's just either for the structural engineer to read it or for the contractor to understand how to build it, right? So it's really critical that besides the concept, besides coming up with a number, they should know how that number, how those values are going to be used by others. Because at the end, it's like it's a group of people who work in through a project, right? It's not only one designer or something. So it's really understand the concept from different points of view. So that's what I'm trying to convey. And every single lecture has its own example. Who is going to be using this number? Why is it going to be using, or what the effect of having a large number is going to have into the structural design, for example. So that combination is critical.
let's say you can work it out in a class, but let's say you have a conservative factor of safety. However, I would imagine that that's going to have an implication of a higher cost that's going to have to be relayed to perhaps a contractor and whoever else is going to be responsible for. So is that factored in at the kind of college stage?
Yes, I think that's what we're trying to convey at the end of the day, not just coming up with a factor of safety like you're saying, right? Um, I'm trying to get him a sense of what that's going to be the effect of this, on a client's pocket at the end, and eventually, if that could kill a project, right? And I've been telling them all the time, it's very critical deciding between shallow footings and deep foundations because the cost is tremendously different. And then some people don't realize that can kill your project, and the project can be like, oh, no, this is not a go just because of your foundation system. That's something that, even if you're doing construction management, or like if you're like a project management thing, you should understand basic things that are not probably thought when you're a student, when you get all these step by steps and formulas, and they don't explain that well. You need to have a link between the industry and application of real world problems with the concepts that you're learning in class, because otherwise you lose excitement, and then you don't know when am I going to be using this, right? Again, is this going to be, am I going to be reading, let's say if you're a structural engineer, am I going to be reading this like somewhere? Or, I mean, who cares about the geotechnical engineer? I'm doing the structures, but eventually you're going to grab a geotech report, and then you need to know, oh, that's the number they taught me in school, and that's how I'm going to use it and apply in my problem, right? So it doesn't matter if you do geotech or not. It's just you have to understand how all these concepts are related into real practice world.
Santiago, this has been a great conversation. Your work on the projects like LAX People Mover and the SoFi Stadium highlights the complexity and importance of geotechnical engineering. Thank you again for joining us today, and to our listeners, if you've enjoyed this episode, do not forget to subscribe to the Ground Investigation podcast or subscribe to the newsletter via LinkedIn for more deep dives into the world of geotechnical engineering. Until next time, keep exploring the world beneath your feet. Santiago, thank you very much for your time once again.
Thank you, Michael. I appreciate the time.